Exponent Rules Part 2. So this is when we're multiplying and dividing monomials. So a monomial is a number, a variable, or a product of a number and one or more variables. So it's basically a whole bunch of parts touching. Remember that these rules only apply with like bases. So you cannot combine things if they don't have the same base. These rules only apply to if they have the same base. So examples of monomials, if you have a number, so 4, if you had a variable, x, or you have a number and one or more variables. So 2x squared y, or ZWA, however you want to phrase it. So all of these are considered monomials because they're multiples of each other. It also includes fractions. So if I have 2a, that would be still an example of a monomial. So product of powers. So product means multiplying of powers. So to multiply powers with the same base, you're simply going to add their exponents and then keep the base the same. So you're not changing the base value. So for this one, if you have 2 to the 4th times 2 to the 2nd, this is the same thing as saying 2 times 4 plus 2. So you're adding those two exponents together. So it's just going to be 2 to the 6th power. Unless it's said to evaluate, that's as far as you go. So if we look at example 2, I have a to the 6th times a to the 3rd. So again, that's going to be the same as a to the 6th plus 3, which gives me a to the 9th power. I can't do anything further because I don't know what that value of a is. And if we look at example 3, you have multiple pieces here. So again, do it step by step. So do your 3's first. So I would have 3 squared plus 4, so that's going to give me 3 to the 6th. I have my x's, so x squared plus 6 is going to give me x to the 8th, and then you have that single y to the 5th at the end. So your final answer is going to be 3 to the 6th, x to the 8th, y to the 5th. Usually we write the variables alphabetically in their order. Again, if it's said to evaluate, then the only thing you could actually evaluate is this 3 to the 6th. So you'd have to figure out what 3 times 3 times 3 times 3 times 3 times 3 is equal to, but you don't have to in this case. If we look down at the quotient of powers, so quotient, remember, is a term that means to divide. It's the result of a division problem. So to divide powers with the same base, again, you're going to subtract their exponents and keep the base the same. So I always look at this division bar as a subtraction sign. So I have the same base, they're both 3's. So now I'm going to take top number minus the bottom exponent, so I get 3 to the 4th. The reason that this works out, I'm going to do it off to the side here, is if I had 3 7 times on the top, so 3, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. If I have 7 3's on top and I have 3 3's on the bottom, I can cancel 1, 1, 2, 2, 3, 3, and I'm left with 4 3's in my numerator. That's how you get this exponent of 4. So that's why these rules work. So if I look at example 5, I have b to the 6th over b to the 3rd. So again, my base is the b. Numerator minus denominator. This exponent is going to give me b to the 3rd. If I look over here at example 6, as you can see, there are 3 parts to it. You have the base of 5, you have your x's, and you have your y's. So do it step by step. If I start with my 5's, I'd have 5. 8 minus 4 is going to give me 5 to the 4th. If I did my x's, x is going to be 4 minus 1, so that's going to give me x to the 3rd. And my y 6 minus 4 is going to give me y squared. So now I just have to rewrite this as 1 unit, or 1 monomial, so 5 to the 4th, x to the 3rd, y squared. Once you get into the habit of just knowing to subtract them, you don't need to rewrite them as individual pieces. If it helps you to keep yourself organized that way, please do it that way so that you don't lose track of exponents. The other thing to mention is, because this one doesn't have a 1 or an exponent, it's understood to be a 1. That's why we were able to do 4 minus 1.